All right, hello. So I'm here still in task 2B for the spectrophotometer project. I just recorded a short video which I shared with you looking at part A, which is the calibration of the spectrophotometer. And so in part A, we computed the pixel ratio, right, was the first task. And then we computed the distance to the left edge of the image. And so what we're going to do in B now is using that same image, using those two reference values, we're going to generate a spectrum. Okay, and so our calibration was done once. These steps to generate our spectrum, this would be done for as many images as you generate with your spectrophotometer. And so let's take a look at this. So I'm going to jump over to MATLAB. Okay, so I'm still sitting in the same directory. So last time we ran this length to pixel ratio. This time I'm going to run measure spectrum. Okay, and so I'm going to do that by typing in my command window, measure spectrum. Okay, and I see a note even down here in the bottom left. Okay, measure spectrum is going to be a function that has input arguments. It has two in this case. The first is that pixel ratio, and then the second was the distance to the left edge of our image. And so, if I jump back over here, okay, I have the values typed in here, but if I were to scroll up, right, my pixel ratio is 0.5670. Right, and you'd use the values for your spectrometer. Okay, and then the distance that I get was 542. Okay, so this is going to be unique to your spectrophotometer, right? So your values are very likely different than mine. Okay, so when I click return, I'm going to get a prompt just like before to select an image. And here I'm still working with this sample image. So I'm going to select CFL bulb.jpg. I'm going to open it up. Okay, I can see this command, or this prompt. You might not see it because the figure opens up in a new window. By default, I have two screens. It puts mine on another window. Okay, but you could read the instructions there, and they're detailed in our document. And what I'm going to do here is I'm going to construct a horizontal line across my image. And so it's going to go from the left edge to the right edge. And so I want to try and position my cursor so I'm as close to the center of my bands as possible to cut through them. So mine, maybe it looks like it's somewhere here around 300. And it's a little tricky in terms of picking the left edge, because if I'm off my image, it won't select it. And so I want to be close to that edge. And so let me see here. If I click once, okay, I've got my line forming. I'm going to bring this all the way across to the other side of my image, right to the right edge. And I want to try and keep this as horizontal as possible. And once I have that and I'm satisfied with my placement, I'm going to double click. Okay. So it pops up in another window, and for me on another screen, but you'll get a figure window 2. Figure window 2 is going to contain your original image and then the generated spectrum. And so what I note in the instructions is when I save this image, it'll be better if I make the image larger here on my screen. So I'm going to click here to maximize my window. So here's my original image, and then here's the resulting spectra. So the intensity versus the wavelength. And so I want to save this as an actual image. And so how I do that is up here in the top left, I have a file, save as. Okay. And by default, it actually shows JPG, which is probably what I used last. But by default, right, it's probably an FIG file format, which is a MATLAB figure format. Right, FIG is probably what should come up by default. If you were to save it as an FIG, that just means you can open it up in MATLAB and edit and manipulate it. For your lab report, though, you're going to want an actual image format. And there's a lot available. JPG, right, would be a common popular choice. PNG is on there as well. Where are you, PNG? I believe PNG was what Windows used to like, right? But there's TIFFs down there. PDFs, I like. There's PNGs, which I believe is what Windows used to like. Encapsulated PostScript is another option. So I think in the instructions I selected JPG, okay, which is good. Here, maybe let me click PNG just for comparison. Okay, but if you select the file format, then it'll give that the default extension. And I'm going to call this example spectrum.png. If you want another file format, I can just do a save as, okay, and then just select that format as well. All right, so maybe I want JPG as well. Okay, cool, and that's it. So if I just minimize this, I can prevent closing it. And if I come over here now, I should see my images in the same window. And so I have example spectrum PNG and JPG. These are located in the same directory where my files are saved. And so you can navigate to them on your computer and open them up. If I right click here and I click open outside of MATLAB, it'll open up in the default image viewer that you have on your computer. Okay, and so that's what my PNG looks like. That's what my JPG looks like. Okay. And you can save it as other formats as well. Now I didn't close my figure windows, okay, but if I click on my computer on my MATLAB window, it'll show my open windows. So I have figure 1 and figure 2, where once I have my images and I'm satisfied, right, I can just close them. Okay. Then the other piece of information that's produced, now I will say, right, these can vary too, from if one person on your team does this to another, these are going to be sensitive to where you place that horizontal line across your image. So if two people on the same team are analyzing the same image, even with the same inputs here in terms of the pixel ratio and distance to the left edge, two people, right, are going to differ in how exactly they draw that horizontal line, which could produce some different values here. And actually I shouldn't have closed my figure window, so let me just open up say my PNG just for comparison. Right, and so what's being displayed here is it says the maximum red intensity and the corresponding wavelength R. We've got the intensity and the wavelength. So what we're looking for is essentially it's identifying the maximum, right, the peak, right, in my spectrum, which looks like it's somewhere around here. So that'd be my peak intensity, right, and they're recording the value. And then the wavelength is your X value, right, where that's occurring. So maximum intensity is 240, and it happens at about 603 nanometers, right? So just beyond 600, right, is where that peak is happening. You'll notice for the others, right, we get multiples, right, and we can come back to that. So green, here's my maximum intensity, 240, and that's where it's occurring, right? And this is just, remember, these are kind of discrete state points, right? And so it might be, I have some small, oscillation within this image, which I can't quite make out with my eye. Okay, and then there's my blue max intensity as well. Okay. But that's the basic of running the code. Give it a try. If you need any help, let your TA or instructor know.